On passing the current, aluminium is discharged at the cathode, but being heavier than the molten electrolyte mixture, sinks to the bottom from where it is taken out through tapping hole. The reactions occurring during electrolysis are Na3LF6 at high temperature decomposes to give 3NAF plus AlF3. Then AlF3 dissociates to give aluminum ions and fluoride ions. At cathode, aluminum ions are reduced into aluminum metal, while at anode, fluoride ions are oxidized into fluorine atoms. Then, these fluorine atoms react with Al2O3. According to the reaction, 2Al2O3 plus 12F, we get 4AlF3 plus 3O2. C plus 1 by 2 O2 giving CO and CO plus 1 by 2 O2 giving CO2. The AlF3 thus produced is subjected to electrolysis as shown above. Thus carbon anode rods are attacked by oxidation, hence carbon rods are replaced frequently. Finally, we have electrolytic purification of aluminium. The method employed is known as Hoops method. In this method, as shown below in the figure, the electrolytic cell consists of an iron box lined inside with carbon. The cell consists of following three layers. A. The upper layer, which grows on passing the current, consists of pure aluminium in the molten state. This layer itself acts as cathode. B. The middle layer consists of a mixture of the fluorides of aluminium, sodium and barium or calcium. The bottom layer consists of impure aluminium which acts as anode. The graphite rods dipped in pure aluminium and copper aluminum alloy rod at the bottom in the impure aluminium work as cathode and anode respectively. On passing the current, aluminium is deposited at the cathode from the middle layer and an equivalent amount is taken from anode, that is the bottom layer. The metal thus obtained is 99.98% pure. Here is a summary of extraction of aluminium. Now we have metallurgy of copper, that is based on self-reduction method. Occurrence. It is not much abundant in the nature. It occurs in the earth crust in the form of following. First one is copper pyrites or chalcopyrites, CuFeS2. Second, cuprite or ruby copper, Cu2O. Third, malachite, CuCO3, CuOH2. Fourth, azurite, 2CuCO3, CuOH2. Fifth, copper glance, Cu2S. It is mainly extracted from copper pyrites. The various steps involved in its extraction are shown in the following flow chart. So we begin with powdered ore, which is subjected to concentration by froth flotation method. We get concentrated ore that is then subjected to roasting in a reverberatory furnace. here we get roasted ore, which is then subjected to smelting in a blast furnace, where we get matte. This matte is then subjected to basimerization in a basimer converter so as to get blistered copper. This blistered copper is then purified, or it is subjected to purification within two steps. First one is poling, the second one is electrolytic refining. As a result of that, we get